The goal of this video is to understand the concept of inverse operations, be able to identify the order of operations in an equation, and apply the inverse operations to solve the equation. Okay, so first thing I want to look at is what inverse operations actually are. Let's say I had the number 10 and I were to apply the operation of adding 5. So what I've done is I've started with the number 10, I've added 5 to it. That's going to be 15. Now the inverse operation to adding 5 would be subtracting 5. So another way to think of it is what is the exact opposite of what you just did. So if I were to add 5 and then subtract 5, I've done the inverse operation, and what that happens is that cancels out. It will undo what was just done. Now if we just think about this, I had 10, I added 5 to get 15. I then take that 15, subtract 5, I get 10 again. So when you perform an operation and then immediately perform the inverse operation, it undoes it. It will completely remove it and cancel it out. Let's go through all the inverse functions. So the opposite or inverse of adding 3 will be minusing 3. So x plus 3 minus 3 gets us back to x. If I times by 3, then I would need to divide by 3 to get back to x. If I put x to the power of 3, then I'm going to need to do the third root to get back to x. If I've got an exponent with a base 3, then I'm going to do a log base 3 to get myself back to x. And if I have myself one of the trig functions, whether it's sine, cos, or tan, then we're just going to do the inverse of that function, which is just the same thing but with a -1 on it, to get myself back to x. So every single one of these is on the calculator. So if I were to do, 10 plus 3 minus 3 gives me 10. If I do 10 to the power of 3, that gives me 1,000. But then if I cube root that, if I cubed root that, I get myself back to 10. If I were to do the log of an exponent of a number, it just gets me the number I started with. And if I do the inverse sine of a sine of a number, it just gets me back what I started with. Again, this works with all the functions. If you do the inverse of the function, it undoes it. Some of the functions that you're looking for on the calculator are going to be written in yellow. And again, if you need to get any of those, we press Shift, which is the yellow button, and then the associated button. So inverse, sine, cos, and tan are written above the sine, cos, and tan buttons. So you can just do Shift sine, Shift cos, or Shift tan to get them. And if you need one of these, like instead of a square root, you need the cubed root, we can go Shift that one, or for any other root, we're gonna have to go Shift and then this one over here. So you're always looking for the inverse function on the calculator to undo it, and that's how you find a lot of those more complicated ones. All right, let's go through some simple equation stuff. If I have a value of x, let's say that x equals 5. If I were to ask you what 2x is equal to, then 2 times x, or 2 times 5, is going to be 10. Let's start with this equation, and what I'm going to do is I'm going to add 3 to the left side. So instead of just writing x, I'm going to write x plus 3, and I'm going to say that equals 5. Now, this obviously doesn't make any sense. If x is 5, then 5 plus 3 isn't also 5. In order for this equation to make sense, I also need to add 3 to the right side and say that x plus 3 is equal to 8. Now this makes sense because 5 plus 3 does in fact equal 8. So if you ever do something to one side of an equation, to keep it true, you also need to do it to the other side of the equation as well. All right, now what I'm going to do is I'm going to see if I can actually get rid of the plus 3 that I just put there. Well, we know from earlier that if you do the inverse operation, it will cancel out. It will cancel out with what you've just done. So the opposite of adding 3 is subtracting 3. So if I add 3 and subtract 3, they will cancel each other. But just as before, I need to do it to the other side as well. Otherwise, I'd end up with x equaling 8, which we know isn't true. So we've added 3 and subtracted 3. The 3's are now gone. However, the x is still there. So the +3 and the -3 cancel each other out. And I'm left with just the x remaining. So x equals 8 minus 3 is 5. So I started with x equals 5. I ended with x equals 5. What a fun time we just had. Now let's go into an example that's a little bit more complicated. Let's say that x equals 5 again, because why not? I'm going to do several steps to this equation. I'm going to apply a bunch of different functions. So let's say I were to triple both sides. If I triple both sides, the left side now becomes 3x and the right side becomes 15. All right, now let's add 4 to both sides. Well, the left side becomes 3x plus 4 and the right side becomes 19. Let's double both sides. So I'm going to double this entire side and double the right side. Now notice how I've put brackets around the left side. That's because I need to double the entire thing, not just part of it. So that's why the brackets are important there. So what I end up with is 2 bracket 3x plus 4 is equal to 38. And lastly, let's subtract 2 from both sides. Oh, actually, let's subtract 7. Why not? Subtract 7 from both sides, and I'll end up with 2 bracket 3x plus 4, close bracket, minus 7 equals 31. Now, when we ask you to solve equations, you generally start at this bit and need to work your way back to x equaling 5. Now you could sit here for ages and just keep guessing numbers until you work out that x is 5, but that is not always going to work out well for you. So what we like to do instead is we like to just apply inverse operations to get rid of all of those numbers until we're just left with the x. So the first number we want to get rid of is the 7. Now the reason we want to get rid of the 7 first is because it's the last thing that happened. Out of all the things that we just did to the x, we tripled it, added 4, doubled all that, subtracted 7. Subtracting 7 was the last thing we did, so that's the first thing that needs to go. So if we add 7, that will cancel out the minus 7. Now everything else stays in the equation except for the minus 7, because we just did an inverse operation to get rid of that, but now the right side will equal 38. Now the inverse operation to timesing by 2 is dividing by 2 to get rid of that. We end up with 3x plus 4 equals 19. This should all look familiar from before. We now subtract the 4 from both sides. We end up with 3x equals 15 because the minus 4 and plus 4 cancel. We are now going to divide by 3 to get rid of the 3. And we are left with x equals 5, which is of course what we started with right up the top. So whenever we're trying to solve equations, we're trying to get back to just x equals something, or whatever pronumeral you've got equals something. And we're doing that by applying inverse operations to get rid of stuff. It is, however, very important that you're able to identify the order of operations. So in this original equation where we had 2 bracket 3x plus 4 close bracket minus 7, it's very important that you can see that you do the brackets first, because you always do brackets first in order of operations. And then after you'd finished solving the bracket, then you would need to do the multiplication, which is multiplying by 2, and then you would need to subtract 7. So subtracting 7 is the last thing that happens, so that's the first thing you get rid of.